Hi everyone, I'm Edi Huang. This is a presentation about SHM, the structural health monitoring. I chose two papers to talk the damage detection. The first paper is the application of wavelet analysis and machine learning on vibration data from gas pipelines for SHM. This paper's idea is that they observe the signal energy in a wavelet scalegram to detect the damaged PAP. The location of the defect can be identified by mapping the location of disturbance in wavelet coefficients to the coordinates of the PAP. In their model, they choose 45 wavelet to analyze. The decomposition is done by up to scale 5, which results in approximation coefficients from A1 to A5, and the detail coefficients D1 from D1 to D5. As we can see in this figure, there is disturbance in A5 and D5 coefficients at 3 seconds of the time. This indicates that there is a defect at location when the load is at distance 3 seconds away from its starting location. So based on this idea, they simulated 95 different cases of defective PAP with different kinds of notches placed at random position, and they trained SVM model by using decomposed acceleration signal. The second paper is multi-way data analysis approach for structural health monitoring, the SHM of cable stayed bridge. The background of this paper is in SHM, this problem, data are usually collected from a large number of sensors, especially for large civil structures like a long span bridge or a high-rise building. So in these cases, a large amount of data will be required. So the idea of this paper is that one excitation event at a specific time produces multiple signals measured by different sensor. This SHM data can be considered as a three-way tensor. That is a three-dimensional array of feature, location, and time. So the new data will be decomposed into three-component matrix A, B, C by using CP decomposition. After this, they use one class SVM to build a model using healthy training events, which is a benchmark model. It's using a one class SVM. They build a model using healthy training events, which are represented by rows of the component matrix C. So in this paper for damage detection, their idea is that after having C new data, this new row will be checked if it agrees with the benchmark model built in the training stage, indicating the condition of the structure. In case of one class SVM, a negative decision value indicates that the new event is likely a damaged event. And for the damage location, in order to localize the position of the damage, when each new data instance arrived there, they analyze matrix B new. The it is able to find anomalies which correspond to damage locations. In this work, An average distance from a sensing location obtained from a new tensor to its nearest neighboring locations is used as uh, a normally score to localize damage. A big change in the score of the sensing location indicates that location is likely have a damage. And for the damage severity assessment, to estimate the extent of the damage, they analyze this decision values returned from the one class SVM model. It is reasonable because a structure with more severe damage will behave more differently from a normal behavior. Different ranges of the decision values may present different severity levels of damage. So to sum up, uh, this paper uses multi-way tensor analysis to identify damage for SHM, including the detection, location, and the damage severity assessment. Uh, so when the new data arrive, the tensor component matrix are incrementally updated and used for the online damage identification. That's all. That's all the presentation. Thank you.